Last week I have shown you how to filter your dataset based on a single condition. Today I will show you how to define more complex filters using unions and intersections. I will reuse the same dataset as last week, where I have a column ID, time, amount, administration identifier, DV, a DVID column to distinguish my PK measurements from the PD measurements, a censoring column, a column study which can take three different values, study 101, 102, and 301, and a column weight. After loading this dataset in Monolix, I can see in the plots that I have the three different studies for the PK data and the same three studies for the PD data. Last week I have shown one example where we have selected the IDs for which study was equal to 101 to work only on the 101 study. And I have shown also a separate independent example where we have removed the lines where DVID was equal to PD to work only on the PK part of the dataset. Now I want to combine these two filters together. To do this, I can start from one of the two. Let's take this one for instance. And I can combine this filter with another filter using unions and intersections. Intersections are created by clicking on this plus button here, and this makes the second line appear. And on the opposite, if I click on this plus here, I create a second filter that I combine with the first one using a union. The key point to remember is that each filter line creates a new dataset and that the unions and intersections apply on these intermediate datasets. It is not an and or on the conditions themselves. The advantage of doing the intersections and unions on the datasets is that we can easily combine actions on IDs and on lines. Let's see what happens if I combine my first selection of ID for which study is equal to 101 with the second filter where I remove the lines for which DVID is equal to the PD, and I combine the two using a union first. I have put on the slides an extract of the dataset with three individuals, two from study 101 and one from study 301. I have displayed the interpreted dataset on which the filters will apply. Watch a previous video if you need a reminder on this point. The first filtered dataset selects IDs with study equal 101 and creates the following intermediate dataset. The second filter removes the lines with DVID equals PD and creates the following dataset. Doing the union of these two datasets means that I will take all the lines that appear in at least one of the two datasets. This is the dataset I obtain when doing the union. These lines come from the first intermediate dataset and these ones come from the second one. So at the end it gives me all the data from study 101 and the PK data from the other studies. Now let's see what happens if I combine these two filtered datasets using an intersection instead. In an intersection, I will take only the lines that appear in all intermediate datasets. This gives me this dataset where all lines are both in the first and in the second intermediate dataset. So if I want to work on the PK data of study 101 only, this is the data I need using an intersection. Let's do this in Monolix. From my project where I have already selected the IDs of study 101, I add the second filters using the intersection. For the second filter, I will remove the lines with DVID equals PD. Once I accept, I can see in the plots that I have the PK data for study 101 only. Of course, I can also combine more than two filters. Let's assume that I want to work on the PK data of study 101 and 102. I could do it by replacing this line by removing the IDs of study 301, so the last one I want to exclude, but for the sake of the demonstration, I will work with several select actions. My current filtered dataset contains the pk data for study 101. To add the pk of study 102, I need to do a union. So I click on the plus for the union, and I will select the IDs for which study is equal to 102. When intersections and unions are combined, the intersections are applied first, as shown by this grouping here. With this setup, we first do the intersection of these two first intermediate datasets, which results in the pk of study 101, and then we do the union with the third intermediate dataset, and this results in this final dataset here, where I have the pk data for study 101 and for study 102, both the pk and the pd data. So this is not enough, as I want the pk data only. So what I will do is to add the removal of the pd, also here using again an intersection, where I remove the lines for which dvid is equal to the pd. Back on the slides, the first intersection gives me the pk for study 101, the second one the pk for study 102, and when I do the union, I end up with a pk for both study 101 and 102. So this setup works, but it's not very elegant because I have twice the remove actions for the pd. Alternatively, I can first do the union of selecting the IDs of study 101 and of study 102, and afterwards remove the pd data by creating another child. I first need to accept this dataset, go back to the filters, and from this step on, create a new child. In this new child, I will now remove the lines for which dvid is equal to the pd. When I do this, I first do a union that gives me all the data for study 101 and 102, and then I start again from this dataset and apply the removal of the pd lines. And then with this setup, I end up with the pk data of study 101 and of study 102. So these filters in two steps is also an option to keep only the pk data of study 101 and 102. And to finish, I would like to show you the complement feature. If I look at this filter that selects study 101 and 102, if I click on it, I can create its complement. The complement includes all the lines which are in the parent dataset, but not in this child. If I apply this filter, it means all the individuals from study 301. As a summary, remember that intersections and unions apply on the intermediate dataset created by each filter line. If you are using both intersections and unions, intersections are applied first. If you need to do the opposite, unions first, then create several children filtered datasets in a row. Have a nice week and stay safe.